Hey guys, this is Einar. I hope that you're doing great today, and welcome to this tutorial where we're going to be talking about regression. Now, regression. To begin with, I'm going to remind you that this data set is in fact the same data set we used in the tutorial about RxY. Now, why is that? Well, RxY is a huge part of regression. You can see it here in the formula here, and we use the standard deviation and the means to calculate that, which are also part of our formula. So what this tutorial is in reality is a kind of extension of the stuff that we talked about in the previous tutorial. So I recommend that you check that tutorial out, you go through it, and then you just continue with this tutorial, because this is, as I said, an extension of that tutorial. So let's take a look at our formulas here. You see them here. This is what we're going to be calculating. If you want to understand them, theoretically, there's a theoretical tutorial about that I recommend you check out too before going through this tutorial. Today we're just going to be calculating things. So let's get right to it and start calculating. We want to plot a regression line using this formula here in our little scatter plot here. So we're going to need a constant, which is the point on the y-axis where this line crosses. We're going to need a beta coefficient, which describes the rate of change in y for each 1 unit increase in x. So that's what we're going to be calculating. In order to calculate the constant, we're going to need our beta coefficient here. So this is the first thing we're going to be talking about, our beta coefficient. Now, that consists of Rxy multiplied by the standard deviation for y divided by the standard deviation for x. And we have these things from the last tutorial, so we can actually just start calculating this immediately. All right, equal to, we're going to need our Rxy, so I select my Rxy here, multiply, parentheses, standard deviation for y divided by the standard deviation for x. So I select my standard deviation for y there, divided by my standard deviation for x, and close that with parentheses, and I get 0.007. There's also a formula for this in Excel. I'm going to show you. It's then lin est, which means line estimator. That's what it means. Now, the first thing we need in this formula are our observed y observations. So we're going to need the observations on our y-axis here. We have that here, which in this case are AFK relationships. So how many friends you have outside of Facebook, away from keyboard. So I select those observations, I separate with a comma, and now I'm going to need my observed x values. So we want to draw a regression line that describes the relationship between these two. I close that parenthesis, and I get the same answer. So it seems like we've done this correctly. Now you might say, wow, what a small number, 0.007. Why is that? Well, consider it for a second. What this means is for each increase in number of Facebook friends, so for each additional Facebook friend you have, you will get 0.007 more AFK friends, which I think makes kind of sense considering how many friends people have on Facebook. If this was a large number, it wouldn't make any sense. If you got one more AFK friend for each friend you had on Facebook, well, people would be having 1,000 friends or 1,500 friends. You know, these numbers are very huge. So don't overanalyze the absolute value of this. You always have to consider the scales of the variables that you're comparing. So this 0.007 will be multiplied by numbers like 500, and then you'll get numbers like 5 or 6, which are, realistic number of friends that people have. So we have this part of a regression curve. Now we're going to need the constant. Now the constant, which is calculated using this formula, is the mean of y minus our beta coefficient multiplied by our mean for x. So let's start calculating that. Equal to, I select the mean of y, which I can find here, y bar, there, minus now our beta coefficient, which we recently calculated right above us there, multiplied by the mean for x. So I select that, the mean for x there. We get a constant of 5.36. So what this means is that our regression line is going to cross the y-axis here at 5.36. Now we're going to use the slope of the line to point us in the right direction to draw this line upwards. That will describe this data set using all our observations. So let's start doing that. We call that y hat. So what we're going to do is we're going to take our constant plus our beta coefficient multiplied by our observed x values, which we have listed there to the left. So we have everything we need to calculate our y hat. All right, equal to, begin with a constant. So I select my constant right there. Plus, now I'm going to need the beta coefficient. So I select that there. There. And I'm going to multiply this by our observations for x. Now, bear in mind here, that we need to put little dollar signs here in between our N31 and N30, because we want these two numbers to be the same for all of these cells as we pull them down. I will not do this for this one, however, because as I pull down my cells here, I want this little box here to follow along, because these are our X values. This will vary, but these two will stay fixed throughout. So I hit enter and I get our first prediction, which is at 5.69, which means when a person has 45 friends on Facebook, we predict that they will have 5.69 friends in their real life, in their AFK life, and that shows up as a little predicted dot right there. And you see it seems to be in the middle, but we need to create a line from this, so we're going to need more predictions. So I do that by holding my cursor there, so it becomes a cross, and I pull down all the way. There, I pull down all the way, and I've already set this so it automatically plots our lines here. So you can see our little lines, our dots here. These are our predictions, and they are aligned in a perfect line. If I right-click there, I can add a trend line. I right-click on one of these, I add a trend line, and I say it's linear, a linear one. So then we get a line. This is actually our regression line. So what these y-hat things represent are different values for y-hat, or predictions based on different values for x. I could stick any value in here. I would still get a dot that was along this line. Say, for example, so if I change, see if I can exemplify this. Let's just add something here. Let's say a person has 669 friends on Facebook. How many friends will they have in real life? Well, we predict they will have 10.18, and that's somewhere around here. So that's an extra dot we add there. I'm going to remove that because it might be confusing, but that's basically how that formula works. And that's how you calculate a regression. You might think, well, that was so complicated. Well, that's because most of our calculation has already been done for us when we were calculating correlation. And that's how you can see the relationship between correlation and regression. They are very intimately related to each other. So have some fun with this. Try changing the values of your own and see how that can change your regression line. Try changing the values of the beta coefficient and the constant. You never know what happens. That's how you learn statistics. Have some fun with this and have a really great day, guys. I hope to see you in the future. Bye-bye.